4 for our common difference. Now your common difference is always the second term take away the first term, or any two terms that are consecutive to each other subtracted from each other will give you your common difference. The nth term is given by a plus n minus 1d, where a is the first term of the sequence. In this case here, a is going to be x. N is the term number that you've got, take away 1, and then d, in this case here, will be minus 4. Sn is the sum of n, is a half of n, 2 times a, where a is the first term, plus n minus 1, which is the nth term, take away 1 times by your common difference again. This is in your formula book. This is also written as Sn equals a half n a plus l, where l is the last term. This formula here is not so commonly used as the one above. This is the one that you're more likely to use. But in this exam question, you're not actually going to need to use this formula. Just telling you all the facts that you need to know about arithmetic and geometric progressions to help us answer the question. For my geometric progression, we will be given a common ratio. And to find your common ratio, you have to do the second term divided by the first term, or again, any two terms next to each other divided by each other. So in this case, second divided by first, or it could be third divided by second term to give you your common ratio r. The nth term is given by a times r to the n minus 1. Your s of n is given in your formula book, which is a, which is your first term, times by 1 minus r, which is your common ratio, to the power of n, all divided by 1 minus r. And your sum to infinity is a divided by 1 minus r, where the modulus of r is less than 1. And again, these bottom two formulas are given on your formula sheet. The bottom question is also worth 4 marks, so a total of 8 marks here for these questions. What you need to do is you need to look at the key bits of information you're going to use from here, work out what is going on in your arithmetic progression, work out what's going on in your geometric progression, and see if you can link them and come up with this equation here. Press pause, have a go at working out the video, answer, and then press play when you're ready to hear an answer. Fantastic work. Hopefully you've managed to come up with an answer to show that you've got this. Now this question is quite tricky because looking at this expression here, it is very difficult to know where to start with this question to come out with this answer. So the easiest place to start is to write down what you actually know and what you're given in the question. So we're going to start off with the arithmetic progression, which is given at the top. So we're told we've got 3 terms of the sequence, which are x, y, and z. Your first term, your second term, and your third term. We know the common difference is -4, so d is equal to -4, and my first term is going to be the letter x because that's the first term given in the sequence. From here, I can then work out what y is. So my second term is going to be my first term plus my common difference, and my common difference is -4. So my second term is going to be y equals x take away 4. Your first term take away your difference, or add your difference, which will be a plus -4, which is the same as x take away 4. To work out the third term, we have got to do the second term, take away another 4. So -4 take away 4 is -8. So your third term is going to be z equals x minus 8. Now if you come up with these relationships, you've got yourself 1 mark. Now we look like we're nowhere near this expression here at the minute, but so far we've managed to get 1 mark. We're going to do a similar thing with the geometric progression. So from a geometric progression, you're told that the terms are x, 15 over y, and z. So x, 15 over y, and z. These are the first 3 terms. We know the first term, again, a is going to be x, and we have got a common ratio because it is a geometric progression. Now to find your common ratio, it is the second term divided by the first term. So my second term is 15 divided by y, divided by my first term, which is x, leaves me with 15 over xy. From here, I can use the formula for the second term, which is going to be a times by r, where a is x times by r, which is 15 over xy. X is cancelled, leaving me with 15 over y, which is what we have got for our second term. This bit here hasn't really helped us, but it's just shown where this information here has come from in the question. My third term is z. Now the third term is a times by r squared. So this comes from this nth term formula here, where it's the third term. So it's a times r to the 3 take away 1, which is squared, which is why it's ar squared. So it's x, which is a, times by r, which is 15 over xy all squared, which is 225 over xy squared, because the x and the x squared cancel, leaving me with 1x in the denominator, and the 15 squared is 225, and y squared is just y squared in the denominator, and this is your second mark. So far we have managed to get 2 marks without actually doing much maths, looking like it's going to come anywhere near this expression here. So we're now going to look at what we've got. The first terms are obviously the same, and the third terms are obviously the same because they've got exactly the same letters. The first terms are just x, so there's nothing to do there. Putting x equal to x, well, it doesn't tell us anything. So we're going to look at the third term. The third term is x minus 8, and the third term here, z, is 225 over xy squared. So these two terms are going to be equal to each other because they are both equal to z. So this is my next step. From here, we're going to solve this equation. So I'm going to multiply both sides by xy squared. Now from here, we look at what we're trying to get. You can see we've now got the 225. So if I take the 225 over to the other side, I've got this minus 225. So I've now got an equation in terms of x and y, and it's got that 225 in, which is what we're looking for in the answer. So this is looking a little bit more hopeful. The initial part of this expression is in terms of y, or y to the power 4 take away 16y squared. Here I've got two terms in terms of x. So I need to get rid of these x's and make everything y's, so then it will look like this expression up here. So I now need to look through the information I've got. So if I look in the question carefully, this second term here on the left-hand side, y equals x minus 4, connects the equation y and x together, which means we can eliminate the x's from this equation I've got down the bottom. So if I rearrange this equation here by adding 4 to both sides, x is equal to y plus 4. I can then substitute in, instead of x, to be y plus 4 times by the y squared, where x becomes a y plus 4, take away the 8, minus 225 equals 0. From here, I'm just going to tidy up this term here. So I've got a y plus 4, take away 8, which is going to be take away 4. And I'm just going to put these two brackets at the front next to each other. I've now got to expand these brackets. So y times by y is y squared. Y times by negative 4 is minus 4y. 4 times by y is plus 4y. And 4 times by minus 4 or negative 4 is negative 16. So I've got a y squared minus 16, all times by y squared minus 225. Again, look at what we're trying to make. It's looking more promising. I've now got that 16, which I've got 16 in here. So y to the 4 is the same as y squared times y squared. And minus 16 times y squared gives me the minus 16y squared. Take away the 225 equals 0. For your fourth mark, this is where you get your 4 marks. You can see the first 2 marks, we weren't really sure where we were going initially with this question, but by the time we put these two expressions equal to each other and then started to rearrange, it makes it easier to see where we're going to get to the answer here. Give yourself a big tick if you got that correct. Great work, well done. The second part of this question says, hence, find the sum to infinity of a geometric progression. I've left in the key facts and information we got earlier on in the question, but are going to be useful in this part here. For geometric progression is down here. Sum to infinity is equal to a over 1 minus r. So we know that a is x. We know that r is 15 over xy. So we can put those into the formula that sum to infinity is a, which is x, minus 1 minus 15 over xy, where r is 15 over xy. So we basically need to work out the values of x and y. Now, luckily, in part A, we came down to a quartic equation. And the equation here in part B says hence. That means use your answer in part A to find y. So we've got to use this answer here to work out the value of y. Once I've got my value of y, I can then work out a value of x. Once I've got a value of x, I can then substitute x and y into this equation here to work out the value for the sum to infinity. Press pause, see if you can work it out, then press play when you've got an answer. Great work, guys. So hopefully you've managed to start with this equation here. Now your calculator is very clever and they will solve this for you. So you can literally just type that into your calculator and get out the two y values that we're looking for. If the question says show detailed reasoning, you must show your working. Now I am actually going to show you how this would factorise. It would factorise into y squared minus 25 times by y squared plus 9, because y squared times y squared is y to the 4, y squared times plus 9 is plus 9, y squared times by the minus 25 is minus 25, and negative 25y squared plus 9y squared gives me the minus 16y squared. And negative 25 times by 9 gives me minus 225. As I said, the calculator will solve this for you. So if you struggle to factorise, use your calculator. From here, we need to get the solutions. So we can say that y squared minus 25 equals 0, which means y squared is equal to 25, or y squared plus 9 is equal to 0, so y squared is equal to negative 9. Here we now need to square root both these numbers. The square root of 25 is going to be 5 or minus 5, but we're only going to take the positive answer here because my y value was a positive number in this equation here. So we're only going to take the positive 5. And when we square root negative 9, we get no solution. So the value I'm looking for here is a y value of 5. Now if y is equal to 5, I can now work out x, because x is equal to y plus 4, but x is what we're trying to find. Y is 5, 5 plus 4 is 9, so x is going to equal 9. I now know the x value, I know the y value, so I can substitute all these values into this equation here. So you will get 1 mark for getting down to the value of r, and you'll get 1 mark for substituting all these values into this equation. There is 1 mark for getting your y value. You can literally type this into your calculator to get an answer, or you can work it out without using your calculator and work it out in your head. It doesn't matter. As long as you end up with the answer of 13.5, that will give you your 4th and final mark for this question. Give yourself a big tick if you got that correct. Well done. The mark scheme on this question shows you've got method marks, which are M1. The M1 depth means it depends on the answer that you got up here. So if you made a mistake somewhere, it can be substituted in. And A1 means an answer mark. Now at A level, to be able to get all the marks, you must show all your working in order to be able to get the answer marks. And this will give you 4 marks in the exam. Here are where the method marks are awarded in the exam, or the answer marks. There is some guidance over on the right hand side to show you where some of the marks could be awarded, or different parts of the examiner to look out for to be able to help give you some marks. On part B, we've got B1, which is also a method mark. So if you came down to here to get y is equal to plus or minus 5, y is greater than 0, as I said, so y is equal to 5. That is 1 mark. Getting the third is your 2nd mark. Then substituting the values in for sum to infinity is your 3rd mark. And then getting the answer of 13.5 is your 4th mark. Give yourself a big tick if you've got these correct. Great work. Well done. If you found this video useful, please share, like and subscribe so we can all get great at maths. If you've enjoyed this video, please don't forget to like and subscribe. Comment below to let me know what you would like to see in my next video. See you next time!